Yeah. I think that the only relevant information about me is that I started the London software craftsmanship community in 2010, and since then I've been heavily involved with the craftsmanship movement, and I have a company called Codurance. We develop software for other companies and do consultancy and training. So before I start, how many of you are developers? Okay. Testers? Right, okay, that's better. How many of you work with legacy code? Quite a few, that's why you are here. It makes sense. So how many of you need to write tests for code that already exists? Okay, right. So how many of you do that in Java? A few, okay. Because the code example will be in Java. But hopefully it will be, there's nothing Java specific in there, so hopefully it will be easy to read. Let me just wait a little bit because there's some people coming. Okay. So this session is about testing and refactoring legacy code. So what I'm going to do is I'm going to take a piece of legacy code. Sorry, there's still people coming. There's quite a few places in front here if you want. So I'm going to take a piece of legacy code. I'm going to write some tests. I'm going to retrofit the test to it, and then I'll try to make the code better. But before I do, it's of course that I cannot, in a 45-minute presentation, I cannot give you a very large code base, right? So we will need to be a little bit more creative. You need to work with me to think that that thing is much bigger than it really is, right? I think that when we have legacy, we find quite a few problems, and I try to put some of them in this small piece of code. So there's lots of coupling. One of the most difficult things to test legacy code is the amount of coupling that that class or piece of code has with other pieces of code. There's low cohesion as well, so that means that it's doing too much, right? So there's too much stuff going on in there. And then I will talk about feature envy. This will make sense for those of you who don't know what it is. I'll show you. This is one of the coding smells. And then anemic domain and violation of single responsibility principle. Those are some of the most common things. So let me just, no, I'm not going to tweet right now. So let me just get this. So tell me, what does this code do? So try to guess what this does. Get trips per user, that's a good guess because of the name of the method. But let's try to figure out what the business rules are. There are three major rules in there. Yes?
It's friends.
It's what?
It's friends. No.
If it's friends, well,
If it's friends.
yeah, friendship is part of it, but there are some rules around that. If the user is logged in or not, but if it's not, what happens?
Throws exception.
Throws an exception if the user is not logged in. That's rule 1. There are 2 other rules. So what happens when the user is logged in?
It depends, is it friend or not?
Right, so, but what happens when they are friends or not? And who is friends with whom, and what is the relationship? Is it bidirectional or not?
Maybe it's like to show the profile of to open profile or to not, if this user friend or not. So to get access to the data of another person. Is he friend, we get access. If not,
right, so basically what he's saying is like, if the 2 users are friends, you have access to the data of the friend. If the users are not friends, you don't have access to the data. How is the friendship, what is the relationship? Do they need to be mutually friends? Or one person needs to be friends with each other? Oh, so it's just one directional. Oh, can we close? Yeah. Right, so what is the relationship? Who is friends with whom?
If it's the same person, no.
Not the same person, no. There are two users in there. There is a logged in user, and there is the user that we pass in as a parameter. They are two separate users, but there is a relationship between the two in terms of friendship.
The user, logged user, friend, in friend list of that user whose profile he is trying to check.
Yes, so 2.5 minutes for almost 100 people to figure out what 16, 17 lines of code does. So the answer was, if the logged in user is friends of the user as a parameter, so the user passed as a parameter has a list of friends. If the logged in user is in that list, then they are friends. Right? So if the user passed as a parameter considers the logged in user as part of his friends, then you can return the trips. So basically, what this does is, imagine a social network for travelers, right? So you imagine that I am the logged in user. So for me to see any data, I need to be logged in. If I'm not logged in, the backend, this is a service class, the backend will throw an exception. The front end, hopefully, will catch that exception and redirect the user to a login page. That was the idea. So, but if I'm logged in, and I try to see the trips of another user, if I'm not friends with that user, I get nothing back. But if that user considers me a friend, I get a list of trips back. Yeah? That's what this code does. So, when we have legacy code, of course the legacy code normally doesn't have tests, right? So, in order to test legacy code, sometimes we need to change the existing code, because the existing code was not written to be tested, mainly because of the hardwired dependencies. So if I need to make any change in the existing code, the rules that I will be using, as I'm using Java, and like it or not, languages like Java, C#, we have very good tooling for refactorings. So I will use my automated refactoring tools to make the change in the production code. I should not be typing in the production code if I'm changing to write a test. The problem is, if I don't have the production code covered by tests, and I change production code, I might introduce an error, and worse than that, I will cement that error with the test. So I will only use automated tools. Let me just close this, so I know my time. Come on, don't die. Yeah. Okay, so the technique I'm going to use is, I have this notion of shallow branch and deep branches. What does it mean? Imagine like when you call a method, the shallowest branch is the shortest path to the exit of the method. As soon as it executes the method, it goes through the instructions. It would be the less instructions that it's called, so the shortest path it goes out, that's the shallowest branch. So when I'm looking at retrofitting test, imagine that you have a very long method. I don't try to understand the entire thing. I don't try to read every single line and compile that in my head. I will browse through the code, and then what I will do is find the shortest branch and just try to understand what that one does. And then I will write a test that represents my understanding of that behavior. And then I'm going to run the test, run code coverage, and see if I'm executing that branch. And if yes, then I will start moving in. So I start with the shallowest branch and move into the deepest branch, because it's easier to build your understanding of the code if you do it this way. If I go to the deepest first, I need to understand the whole thing. When I'm refactoring, I do the other way around. I go to the deepest branch of the code and start refactoring from there, because that deepest branch has everything that it needs to do its job. So it's much easier to start extracting from there. So the code base that we looked at has two hardwired dependencies. So this is the class under test. This is the trip service. This is a backend class, right? It belongs to my domain model, if you like. And it talks to two different classes. One is the user session that is a singleton, right? And this is hardwired in there. I don't have access from outside. And then it also talks to a trip DAO. This is the old naming for repositories, right, in the Java world. And this is a static method in there. So I will need to take that code and deal with that. But while I'm testing that trip service class, I cannot break the system, which means that I cannot change the public interface of that class. Otherwise, I will cause a ripple effect in the code. Imagine that there's loads of code that is using that service. So if I change the constructor or the method signature, I'm going to break a lot of things, and I don't want to do that. Right? So, OK. So let's have a look at it. Let me just get some. It's quite nerve-wracking to code in front of loads of people. So you need to bear with me. And keep an eye. If I do something stupid, let me know. So the first thing is to look at the shallowest branch, right? So the shallowest branch is this if statement. So I just go through. I'm looking like Robocop or something. So the shallowest branch. So I ignore the variable declaration, and I look at the shape of the code. I know that there is a big if statement in here. There's loads of stuff in here. I don't try to understand that. I just jump. I just look at, this is the shallowest branch. So if the logged in user, so there is a kind of a validation of the logged in user in there. If the logged in user is not there, it throws an exception. Everything else I ignore. So with this understanding, I try to write a test that represents that. So let's say, so validate the logged in user. So this validation expected, I expect that user not logged in exception to be thrown. The table is, OK. So then I need to, of course, instantiate the class and execute that method. So at that point, when I'm doing this, I don't try to think too much about the code. I think that one of the mistakes that we make when we are retrofitting tests is to try to compile in our head instead of using our tools. So this is not going to work. So before you try to execute in your head, write a test and run the code. See what happens, right? In this case, I was expecting, if I instantiated the class and called the method, I would expect this exception to be thrown. However, that's not what the compiler is saying me. It's saying that there is a collaborator call exception in the user session. I'll show you what's going on. That is this line in here, right? It's blowing in here. I removed the code from the user session. So if I step into it, the real code was trying to get the HTTP session from the web server. So it would throw a different exception. I just put this exception in there so that we all understand. So basically, I'm testing the trip service class, but it's also calling the user session class. And that breaks. But I don't want that to be called while I'm testing the trip service class. I want to kind of mock. I want to isolate the trip service out. So I can just focus on the user session. So I just focus in one class. So this is my first challenge with the legacy code. So this is the problem here that I need to solve now. I cannot test this class while I don't solve that dependency. Who read a book called Working Effectively with Legacy Code? One hand, expected. So read this book. It's by Michael Feathers. There is one technique in there that is definitely worth the whole book. It's called a SEAM, S-E-A-M. So SEAM in English, I'm not native speaker. So SEAM is this thing in here that binds the body of my t-shirt and the sleeve of my t-shirt. It's just this line, right? So when we have a hardwired dependency, we need to create this seam. So we need to explicitly create a seam. That means that where the two classes, the trip service and the user session, where they meet. Remember that I cannot change constructor, I cannot change the signature, but I still need to test. So one way of doing that, I can select this bit in here, and I can extract a method. And I can call it logged in user. And I will make it package private. I think that that's fine. So what happens, I extracted this method in here. So now instead of having it in there, this is the seam. This is the place where the two classes meet. In order for me now to test this class without breaking the entire world, what I can do in my test, I can do like a private class, testable, trip service. I can extend the trip service class, and I can override the method that I want. And in there, I can make it do whatever I want. So for example, now. So this way, I'm making, what I want to do is to mimic what this is doing. So for the test that I'm writing, I need the logged in user to be null, so that the code will jump in here. So instead of using the real trip service, I can instantiate in here the testable trip service. And if I run my test now, it will go green. And if I run with coverage, so let me just make this small. So the code coverage is great. I normally don't like code coverage at all. I don't think that is a very useful metric. But it's very useful when you are retrofitting tests for legacy code, because I need to know, imagine like if this was much bigger, hundreds of lines, you might have multiple points in the method that returns the same thing. So this way allows me to visualize if I'm covering the right branch, and also what is left to be tested, right? So although this is good, this test is really bad. Because I just wrote it, I know what it does. But if I look at what this test does, so for example, if validate the logged in user, if you just look at the body of the method, the subject of the test, that is the logged in user, is nowhere to be seen. And remember when we were looking at the test, there was some confusion of which user was which. And the logged in user is buried in here. So we can do a few things to make our test clearer. It's not that it's needed, but it will enhance the readability. And so for example, I can create a logged in user in here. And I can create a field, let's say user, and then I can use it in here. So if I run, I still have, so at least I'm now introducing the concept. But also the nulls are quite bad because they don't mean anything. So I know what a logged in user is. But in this case, the user is not logged in. So I need to express that. One way of expressing that, I can call it a guest. I can say it explicitly, like the logged in user is not a logged in user, he's a guest. Because normally in a web app, that's how you would call someone that is not logged in. And then this one, I make it to be null. And this one, I don't really care much. So I can say just some user for this test in here. So this way, I have a test that at least tries to express a little bit better the intent I had. So the next is, I need to go in. So now I know that this is what's left to be tested. The next feature in there is when the users are not friends. So when the users are not friends, I should get nothing back. But I can also express a little bit better. So for example, the user that is passed in, I can create a user to avoid confusion that has friends, has trips, is just not friends with the logged in user. So even a user with friends and trips, if I try to see the trips, I won't see anything. Just for you to understand, so the user is just a data structure that was tailored to this exercise. So I put that everything in memory. So the user class has just trips and friends as a list. So in the real code, we would go to the database, fetch the user. So I just trimmed it a bit so it's easier for the exercise. So in here, let's express first of all the business rule. So a trip service should not return trips when users are not friends, right? So don't look at the screen right now. Oops, never copy and paste. Copy and paste is a very bad practice. So now what I don't want a guest, I want a registered user. So the logged in user is a registered user, and I will create a user in here. I really use a lot of constants. Constants, I don't use constants to reuse them. I use constants to enhance the readability, right? So here, this some user now, I want to make it very explicit that is a stranger, for example. So you can play with the language to express your intent. So the stranger, for example, is a user, and the stranger, I will add a friend that is another user, and I will even add a trip, let's say to London. That's where I'm from. And here my test would be, I'll have a list of trips, and I will assert that my trips.size will be 0. So that's my test, yeah? So let me create all of these things. So this is a new user. That's a trip, and let's statically import this. Right, so let's run the tests. Okay, let's run the coverage. Okay, so as we can see, I'm getting there. So the coverage is helping me to figure out what am I testing. First of all, it's validating my understanding as well, right? So I express my test according to my understanding of the code. I run the test and see if it does what I expect it to do. So now I will refactor because there is some duplication. So the trip service, for example, can be extracted as a field. Let's put it in here. Let's move the initialization to the top. And then we can delete this. Let's run the test again. Shit, I'm going to run out of time. I can see that now. So let's write the next test. So should return trips when users are friends, right? So let's, again, borrow this piece of code in here. Oops. Right, so now, I don't want a stranger. What I want is a friend. The friend, I also want it to be friends with the registered user. I want to have 2 trips. I'll put Moscow in one. So let's create the constant in here. And the test, now I expect 2 trips to come back. Okay, that fails. The reason that it fails is because now it's executing this line in here. This line is going to the database as well. Again, similar to the user session, I removed the code. This would go to the database, have JDBC code. I just removed it because it would throw a different exception, probably a JDBC exception. So in order to solve that, I'll do exactly the same. Extract, trips by, make package protect. I normally, when I have just one parameter, I combine the name of the method and the parameter so it reads nicely. So I can come in here, override the method, and in here, I can make that method return whatever I want. And in this case, the user has 2 trips, so I would say, instead of going to the database, return the 2 trips that the user has. So user.get trips. So if I try to run that now, I have all the tests green. And okay, so this is a good time to commit, actually, Git, before I do something stupid. Trip service unit tests. So now I can just refactor things a little bit. I can move this initialization to the top. So this way, my methods now have the 3 blocks, right? So depending on how you like, so this given I have a friend with this data, when I see when I try to see the trips from that friend, I get 2 trips back. Or arrange, act, and assert, whichever way you prefer. But I will add a builder as well, because this gets very bloated. Mainly when you have a lot of data, it can be quite cumbersome, so I normally prefer to write it like that. User friend is, so a friend is a user that is friends with another user and a registered user. Oops, there is a, what did I do? Wow. Wow. Thanks, IntelliJ. So, with trips to London and Moscow. So that's kind of, let me just make it a little bit smaller. So this is what I want to use instead. So now I need to make it work. I'll put that in a builder. User builder. So that's what I would like to have instead. So let's try to create in here first. Public static class user builder. So now I have the home for this. User builder. Return new user builder. So now I can start creating this method. I just need to return the same object. So I can, let me just make it a little bit smaller. Well, what I can do is move this one there a bit. So I can, friends, I can make it a var args. So here I can pass as many as I want. Friends. And I can assign that to a field. And let's do that with the other one as well. User builder. So this will be trips. This trips equals trips, return this, create the field. Oh, come on. I'm trying to rush because I'm going to run out of time. So here I actually return the user that I want. And I need to populate the user. So add trips to user, add friend to user. Let's create those 2 methods. So this is no friends, shit. Let's put trip. No, I want trip. Trips. Trip. So user dot add trip. So let's create this method as well. Let's select the right thing now. User dot add friend. Okay. So now it should compile at least and probably run. Great. So what I will do, remove that. I'll do that here as well. User stranger is the user builder, is a user, friends with another user, with trips to London, build. Java developers don't type, we autocomplete, right? So, okay, great, so finally, and then I can move the builder out to its own class. So fine, and then I can just touchly import these, and the test looks a little bit better. So builders are great if you want to make the code more readable. So let me commit this quickly. So, okay, so in terms of testing, I'm done. Now I can start refactoring. Refactoring, I normally go to the deepest branch. The deepest branch is this one. The problem is that this one is just a delegation for this, so there's not much that I can do. So the deepest branch ends up being the for loop, so everything that is inside this if. Here, we have a code smell. Remember that this was a social network for travelers. This for loop represents a business concept. This for loop is trying to check for friendship, right? So normally, our first instinct when we are dealing with legacy code is to extract a method. That would definitely work. We would extract that for loop in a private method, which would make the public method better, but we wouldn't be solving the problem. In a social network, there are hundreds, if not thousands, of tests of friendship. And because this for loop doesn't have a proper home, this for loop was spread all over the code base. So instead of, before you extract a private method, you need to ask yourself, does this behavior even belong to this class? Right? So in here, this is what is called a feature envy. We have a class called trip service. The trip service goes to another class that's called user and say, hey user, give me a list of your friends. And I'm going to do an operation that is only related to that data. So in this case, the trip service envies the user. It wants to be the user. We can apply a technique that's called tell, don't ask. So we push behavior down. It would be much better if I went to the user instead and say, hey user, are you friends with this other user? And all of a sudden we can move the entire logic to the user class and it has a home now. Every time that I want friendship, the user now can deal with that. So I will test drive that code. So let's take the user class. The user class doesn't have that behavior, right? So let's make the user class to have that behavior. So I want the user should inform when users are friends. That's the behavior that I want. So what I want in here is I want to assert that a user is friends with, let's call Bob, right? And this should be false. So I will speed up a bit. Normally I work in smaller increments and I triangulate, but I'm going to speed up. So, and let's say that I ask the same to Paul, and that should be true. So basically what I'm defining in my test in here is say, I want the user to have a new behavior that is a method called isFriendsWith, where I pass a new user, and according to the user that I pass in, it should give me true or false, right? So now what I need to do, I need to create this user. I can use my user builder that I have. How cool is that? So that is friends with Paul build. So that's my test. Right, let's create Paul and Bob, new user. So let's create Bob as well. So let's start to import this. And finally, that's the method that I want to have. So this will create there. This will be another user, right? So if I return false, just make sure, let's see the test failing first. Okay, and then to fix that, as the user has a list, so let's say friends contains another user, that should make it work. Great, so let's commit that. User is friends with another user created. Okay, so now we can go back to our trip service. So let me run all the tests again for the trip service to make sure that I'm in the right place. Okay, so I have 10 minutes, I need to rush. So now, what I want to do is, one of the problems with refactoring legacy code is that the variables are defined at the top of the method, and they are used all over the method. I want to get rid of all the variables, and I want to move them as close as possible to where they are used, and then remove them all. This will allow me to break my code apart. I'm going to try to show you. So for example, this is friends flag. It's just used inside the if. So let's move that inside, run the test. So this we need to it's not because we have tests. We shouldn't go crazy because we have tests. Some people have tests and they all say, oh, it's all green, and they go on a refactoring spree. They want to change everything. No. One move, run the test. One move, run the test. One move, run the test. If the test goes green, or goes red, once you are one step to be back to green. Control Z, back to green. So you can make sure that you are not going off a tangent. And try to do all the refactorings while you are in the green, if possible. So now, for example, instead of using the for loop to set the flag, I can ask user is friends with the logged user. And then, if I run the test again, it dies. So logged user could be logged in user, because that's a different thing. So, oh, press the wrong button. Go away. Okay, I'm back. So let me move these a bit. So now I can start inlining the variable and get rid of the variable. So this variable here is only used inside the if. Let's move that closer. Run the test. It works. So now, this if statement here, this else, this has a name. This is in design by contract. I'm trying to remember his name. That creates design by contract. And AFO, the language. Meyer, oh fuck, forgot. Anyway, so this is called a guard clause. So basically, like, it's a clause that says, like, if the data is not valid, don't execute the main thing. The main thing, the purpose of this method is this. However, if the user is not logged in, I won't allow the method to do its job. This is what a guard clause is. In AFO, the language, this is a precondition, or design by contract is a precondition. So you never do that. You never wrap your main code in a guard clause. So basically what you can do, you can invert the if, and then you can remove the redundant else. And this way, you break the block. So the cool thing about, just run, yeah. So the cool thing about that is now you want to break your if statement apart. So the top part is responsible for validation. The bottom part is responsible for the business logic. So let's get rid of all the variables. Inline this. This strip serves, what I will do, I'll do an intermediary step in here. I will return new array list in here. I will return this from here. And I probably can delete this line. Let's see if I'm still green. Yes. So this is an unused variable, delete. And now I'm going to introduce the evil ternary operator. Some people absolutely hate this. Oh my God, that's horrible. I like it. When you have 5 lines of code, 6 lines, I don't care. So I think that this is much better. So, okay, so this is now taking shape, right? So let me commit this. Oh no. Git commit trip service internal refactoring. No, it's 12:05.
Yes, we need to have some time for questions.
We probably won't have. So people need to go. Yeah. So people can grab me outside, and I'm happy to speak to them. So, all right, let's try to finish this. So I need to get rid of this. Oh, fuck, I have 5 minutes, and I won't finish that. So this is a smell, right? So every time we do this, means that you have a hardwire dependency. This should not happen. So this code has a fundamental design problem. This code is a trip service. This belongs to your domain model, to your backend. The user session belongs to your delivery mechanism. Your model should not know anything about session, right? That's the problem. That's the fundamental design problem. So instead of having the model accessing, because you have a circular dependency, you have the front end or the delivery mechanism knowing about the service, and the service knowing about the other class. So you have a circular dependency. What I would like to do is to pass the logged in as a parameter and not check in here. So this is a slightly more dangerous refactoring because it will break stuff. But that's fine. So, for example, what I can do, but I can show you how to do that in a safer way. I can introduce a parameter. I'll call it logged in user, and I'll set the default to null. So what it does, it creates a parameter in here and went through the code base and changed everything to put null. What I would do in the real code, I would substitute the null with the call for the session anyway, so that would work. So now I'll fix the tests. So I'll put here the registered user, here's the guest. So if I run my test now, it should still all be green because I'm not using the parameter at all. Great. So now I want to use these instead of the methods. So I just need to change this to be using the parameter now. I run. Great. So this method is not used anymore. So I can safe delete the method. Yeah, thanks IntelliJ. So that removed from here as well. So now I don't need the logged in user anymore in here. So I can remove that from here and from here and run the tests. Great. Go away. Right, so, okay, the last one is the trip DAO. I want to inject that as well. The problem with the DAO is that it has a static method. If I remove that, I break the whole world. So I cannot do that, but I can do a trick. So what I can do is say public list, because I need to have a instance method in order to mock. Trips by user, and then return. I can redirect to the other method. So doing that, now I can mock this method and move all the code to use the instance method. And when there's no reference to the static method, I copy the block, put in the other one, and delete. So this is a technique that you can use. So now, going back to the trip service, 3 minutes. Never. So, okay, let's mock that. So I want to mock the trip DAO and inject and then control and get rid of the testable thing. Right, so run mock. So this is Mockito in Java. So what I want is a mock trip DAO. Yeah, thanks. And then the trip service is in the test is being assigned to the testable trip service. I don't want to use the testable trip service anymore. I want to use the real trip service. So what I will do, let me create a real trip service. And in here, I will instantiate the real trip service. And gradually, and I want to pass the trip DAO into the constructor. Right? And of course, not to break the whole world, I can create a constructor, empty, and I can initialize this here. So this way, nothing's going to be broken. So what I can do now is go test by test and start replacing the testable trip service with the real trip service. Because one test should break because of I'm not doing these anymore, right? So let's put okay, and this last test should break. So the reason that it breaks is because now we are not overriding this anymore. We are calling the real one. Yeah. So I have so if I run the test, it's throwing the collaborator call exception, right? So as expected. So what we need to do, we need to use our mock. So instead of calling the static method, I'll call the instance method. And if I run that now, it will change the error. Now it's saying, hey, your test was expecting 2 trips, but I got 0. Remember that in the testable trip service, I was doing that. But now my mock is, I need to configure my mock to do the same thing. So I can say, given the trip DAO dot trips by a friend, oops, not filter, friend, it will return, not filter, friend trips. That's the same behavior that I have that I had in there. So if I do that now, it's all green. I'm finishing, I promise. In another 2 hours, I'll be done. Oh no, there's a compilation error. So this could die, this could die, this could die, this could die. Yep, and this real trip service makes no sense anymore. It should be called real because there's just one. So it could be trip service again.
Sandro, sorry for interrupting you.
Yeah.
We're out of time.
Oh, can I have 2 minutes? All right, so it's just this. So it's done. So now we can just validate the logged in user. So there is a bump in here. See this, the language is bad, yeah? So I can express what this is. So I can say no trips. And if I do this now, so let's make sure that I have all green. And if I collapse that now, what I have in here is a trip service should validate the logged in user. Validate logged in user. A trip service should return trips and users are friends. If user is friends with logged in user, return trips by user. A trip service should not return trips when users are not friends, otherwise return no trips. So this is exactly the same code base, exactly, right? But it's just trying to make sure that my tests express my business rules, but also mainly my public method should tell me the story, and that should match, right? So that's it. So I'm running out of time, so I would talk about other things, but that's, in terms of the code, that's it. So thank you very much. If you have questions, get me outside. Yeah?
Questions, please. And you have questions in your laptop. File.
So. No, the first question is no. I just kept the same behavior because I didn't want to break the whole thing. But in a web app, the check for if the user is logged in should happen in the front end. The backend should not even receive the logged in user as a parameter at all. The front end should know, like, can you access that service method? And if the answer is no, it blocks in there. There's a filter that before it even calls the service, the filter will say, is this guest trying to access a protected service? If yes, redirect, but doesn't even get there. So I just kept the behavior, not to break the entire world, but I wouldn't pass. How do you check if your application performance has been decreased after refactoring? You can have like JMeter, you can have loads of other tests that you test your application as a black box. So then you have like your, what's the name? So basically in UBS we had like a trading platform and we would bombard our system with thousands of trades and the test would fail if it reached a threshold of time. So we would still use the same test in there. Is it okay when a QA edit developer's code? I don't think so. I think that we shouldn't have this distinction. I think that the two should work together, right? They should pair with the QA. I don't think that people changing code in isolation is a good idea. All right? Okay, thank you. Cheers. All right.